IEA PVPS Task 15 started almost 10 years ago, and the main goal is to really support the industry to bring forward the implementation of the so-called Building-Integrated Photovoltaics into our energy system. So we need more products, more solutions in order to activate the envelope of our buildings. So BIPV stands for Building Integrated Photovoltaics, and are building components such as facade element, roof element, shading device, or any accessory that clad our construction and our building that are activated, so that integrate in their material photovoltaic solar cells to produce renewable energy. It's so important because, especially in our urban environment, in our cities and villages, the space for conventional large PV installation is not so much. Therefore, we would like to use already built and constructed surfaces to produce renewable energy for our target. Moreover, BIPV has another big advantage. This is saving materials, because we are using material to clad and produce our buildings, and we activate them. So we can save some embodied energy to produce renewable electricity. Another advantage in comparison to conventional solution is that BIPV is nice and aesthetically pleasant and can be really used as a conventional building component by architects and planners that normally have difficulties to use appliances such as conventional PV. So BIPV are really fully integrated into the design of our architecture. So BIPV in our building is not for free. So the cost of this kind of solution are still quite high, especially if we compare it with the conventional building material, because we have to integrate a new technology, and we need also to train planners and architects in how to deal with this almost new technology, we can say. Therefore, there are challenges that within our group of experts coming from everywhere, we would like to address and solve, if possible, in the next 4 years of the task. So one of the main challenges is really to create a clear and useful regulation framework in which industries and designer, engineer, and architects can really find the best solution and best approaches in order to work properly with the technology. In this regard, we have set that an activity in which we would like to address, for example, fire safety for BIPV solution, how to improve and model shadow tolerance of BIPV installation, or how to assess also glare for glazing a facade integrating PV, and so on. Another challenge is to support policymaker and market analysts with providing data on the potential, on the real potential of BIPV in our cities and our society, and also to develop a new procedure and new approaches to assess also the environmental footprint of this technology that now is becoming really relevant and hot topic for the building industries. Another challenge we would like to solve and overcome within the task 15 is to develop programs, training programs for professionals and for students in order to bring the topic of BIPV into regular program of architects and engineers, but also to train experienced architects and planners in this regard. So industry is fundamental for the task. So we try to collaborate with industry. So first of all, it's really important that we are able to involve as much as possible industry, providing a new solution for BIPV. And how to support them. So what we are willing to provide is to create documentation in the form of report or digital material in which we try to explain the potential and the opportunity of the technology. In order to do that, we want to involve the industry as much as possible. Therefore, I really welcome different industry to come back to us and contact us so that we can organize also events, such in the form of a workshop or meeting, in which we can show the results of the previous phase of the task and to develop new programs in order to be as much as possible close to the industry needs and the interest of the market.